Welcome to all for this today's class. In today's class, we are going to learn about the autoclave method in the composite manufacturing. Actually, it is an advanced technique for high performance composites. About the autoclave method, it is one of the most sophisticated and widely used techniques in the composite manufacturing, especially when high strength as well as high dimensional accuracy and aerospace grade quality are required. This autoclave method is very suitable. Autoclave. In this autoclave curing uses a high pressure, high temperature vessel to consolidate the composite laminates. It is often made from prepregs or pre-impregnated fiber reinforcements. This method is the gold standard in industries like aerospace, defense, spacecraft, and medical devices where flawless components are essential. What is an autoclave first? An autoclave is a pressure vessel designed to process the composite parts by subjecting them to elevated pressures about 6 to 10 bar and temperatures 120 to 180 degrees Celsius under controlled conditions. It allows the simultaneous applications of heat and pressure to remove the air and volatiles, to improve the fiber resin bonding, to consolidate multiple layers, to ensure void free, as well as to ensure the high strength components. So this is about the autoclave, and the working pressure, elevator pressure is 6 to 10 bar, as I said, as well as the temperature is 120 to 180 degrees Celsius. And what is the principle of the autoclave method? Actually, it is the method based on the thermal energy to activate the resin matrix, as well as the pressure to consolidate the layers. This is the method for the vacuum to evacuate air, moisture, and volatiles. Together, these elements help cure the composite uniformly, minimize the defects like delamination, voids, or fiber misalignment. Next, the materials used here are the autoclave process primarily uses the prepregs, as I said earlier. Prepregs are the reinforcement fibers pre-impregnated with partially cured thermoset resins. Actually, it is epoxy resin. As well as fibers like carbon fiber, glass fiber, aramid fiber, like this is called Kevlar. The matrix system here, epoxy and finite esters, phenolic is matrix. Then step-by-step process, as I said in the hand layup as well as layup, all the things will come into picture here. One is the tool preparation, second is the layup, third one is vacuum bagging, then vacuum application, autoclave curing, then cooling and removal. These are the things. Then what are the autoclave cure cycle? Okay, autoclave cure cycle parameters. We should know these things. The parameters are temperature, ramp rate, dwell time, pressure, vacuum, cooling rate. These are the autoclave cure cycle parameters to be considered. In the temperature ramp rate, it controls how quickly the pot heats up. And the dwell time means that the time at which the pot is held at a target temperature for resin curing. And the pressure here, the pressure is applied externally to ensure the compaction and consolidation. Vacuum is maintained throughout to remove the volatiles and the air. Then cooling rate is controlled to prevent the warping and residual stresses. And we have the advantages in the autoclave method. Let's have the feature. Feature is high quality. High quality benefits to excellent mechanical properties near zero voids. Next one is dimensional accuracy, so that the tight tolerances and the complex shapes are also possible here. And the surface finish, it smooth and paint 3D surfaces. The solidity, that means the compatible with the various fiber resin systems. Reliability means here repeatable and consistent results. Then we should know the disadvantages of the autoclave method. Here the limitations are high cost. That means the equipment, tooling, and pre-preg material are expensive. Then slow cycle rate. That means curing time may take several hours. Then size limitation. It is limited by autoclave chamber dimensions only. Depends on the chamber dimension, the size limitation can be calculated. Then we need the skilled labor. So it requires expertise in the layup and the processing. As well as the applications of autoclave cured composites are in aerospace. That means wing skins, fuselage panels, helicopter rotor blades, interior cabin structures can be manufactured here. In spacecraft, the satellite structures, payload shrouds, antennas, and reflectors also possible to manufacture. In defense field, radar, domes, UAVs, and drones, armor panels. In medical point of view, prosthetics, MRI compatible surgical instruments are also manufactured. In motorsports means monocoque chassis, suspension arms, engine components are manufactured by using this method, autoclave method. There are some comparison between the autoclaves and out of autoclaves are there with respect to the criteria: pressure, quality, cost, surface applications. So everything is superior in the autoclave method. So what are the innovations in the autoclave technology now? We should know that automated tape laying and fiber placement reduce the manual layup time, as well as the smart autoclaves with IoT and artificial intelligence improve the monitoring and reduce the cycle time. Hybrid cure cycles allow the pot heating via mold and autoclave to save the energy. Autoclave consumes high energy and produces carbon emissions, prompting a shift toward and thermoplastic composites. However, for precision critical applications, autoclaves remain that means it is not replaceable. So these are the things finally we can have a summary about autoclave method. Then we can move, we can wind up. This method is a cornerstone of high performance composite manufacturing, especially where zero defects and precision are non-negotiable. Despite its high cost and complexity, it remains the benchmark for quality and strength in aerospace, defense, and the medical industries. That's all about the autoclave methods in the composite manufacturing. We will see the different topic with different points in the next class. Thank you for watching this video. We will see you once again. Thank you and all.